Hi, this is Divya, Assistant Professor, Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about the need for the solution. What is the need? This is a continuation of the previous video where we saw about the why we need the bipolar junction transistor, the importance of the bipolar junction transistor. And now we are going to need for the solution. What all the need we need, we require to use this bipolar junction transistor. Limitations of vacuum tubes by using, the technology evaluation. In this right side we have a diagram that technology evaluation in previous days, that is during 1940s, the vacuum tubes has been used, okay, to evaluate a certain type of diseases. Okay, now it has been transitioned to this transistors, that is during 1950s, okay, 50s and plus till now, that is bipolar junction transistor has been used. This bipolar junction transistor enables compact, reliable and efficient biomedical instrumentation. This provides a compact one, okay, where the size of the transistor will be very minimum. We can design it to a very nanoscale level also, okay. So the size of the device will be very compact and very minimum, and it will be very helpful for all the patients to use it by their own. Okay, so this BJT is specially used. BJT enables compact, reliable and efficient biomedical instrumentation. What are the limitations of vacuum tubes? Since we have used vacuum tubes in the olden days, right? What are the limitations we have? That is larger in size. Okay, we have high power consumption for it. See, to use a vacuum tubes, right? We have to the power consumption of the device will be very high, where high pressure has to be given. Likewise, the high output will be provided. Minimum out will be provided, whereas the higher pressure has to be incorporated. It will be larger in size, okay. Fragile construction. The construction of the vacuum tube will be very bit difficult, okay. It will be very bit difficult to handle for the clinicians. It will not user friendly, okay. High power consumption. Heater required, okay. A heater is required to use the vacuum tubes. Clinical challenges. What are the challenges they face? Non-portable devices. As I told you already, with the help of these vacuum tubes, the size of the equipment will be very large, and it will be very difficult for using for the clinicians or the doctors. Since it is of very size, these are the challenges. What are the challenges they are facing is that non-portable devices. It is a very large device. It is not very portable. And then bulky equipment, the entire system will be very bulk. It will be very difficult to carry from one place to another. Okay, then limited precision. The output of the equipment will be very low, and high maintenance. Since the device is very high, very huge, the maintenance process will be very high for these clinicians. What is the technology gap we have here is that miniaturization limits. Okay, since it is a non-portable device, the equipment is very bulky, right? The miniaturization limits. The size of the device development is limited. Integration challenges. How the two components to be integrated. We have challenges during 1940s when we are using the vacuum tubes. Scalability issues and cost inefficiency. We have very vast cost. Okay, to purchase a component, right? To purchase an equipment, the cost will be of very higher, where it will be very difficult to purchase an equipment during 1940s, when we are using the vacuum tubes during that stages. Okay, so these are the need for the solutions. What are the solutions we need? The limitations of vacuum tubes has been seen. clinical challenges. What are the clinical challenges they face, and technology gaps has been identified here. Okay. Next, we are going to see about the main structure, BJT structure, and the type of this BJT. Here, as I told you already, this BJT is a very important one where it produces a very high efficiency, which is specifically designed specifically this common emitter configuration is used in all the types. Okay, here generally this BJT is used, it has three terminals, that is base, emitter and collector. Okay, base, emitter and collector. We have two different classifications is that is one is NPN and another one is PNP. Okay, NPN and another one is PNP, where we can find the difference. See, the symbol has been mentioned over here, that is base. We have three terminals, base, emitter and collector. Likewise in PNP also we have base, emitter and collector. The difference between PNP and NPN transistor is that where the current flow, which is flowing outside the emitter, see, we can see the arrow mark over there, arrow mark which indicates the current flows which outside the emitter, that indicates the NPN transistor, whereas the flowing of current is towards the base, that is from the emitter to the base. Okay, that shows the PNP transistor. Okay, as I told you already, it has three terminals, it is emitter, base and collector, and we have three parts, that is NPN and PNP. Here this emitter, okay, emitter will be a larger in size, smaller in size. This base will be of very smaller in size. When compared to the base, emitter will be of a little more bigger in size. Okay, whereas this collector will have comparatively will be having a very big in size. Okay, a base will be of very minimum, which is slightly doped or very thin. Emitter is of moderately doped. Collector is of moderately doped and emitter is of heavily doped. Whereas the size of the collector will be very higher, that is very larger when compared to the emitter and base. Okay, as I told you already, it has three terminals, two junctions, okay, J1 and J2, which is between NP and PN. Here it is PN and NP, and the two methods also, two types also will have two junctions, J1 and J2. It is a current control device. Okay, it is a current controlling device where it is specifically used for the amplification purpose. Okay, this BJT is specifically used for the amplification purpose. Thank you.